Okay, we are live on YouTube. We are recording here.
Yes.
I would like to start by welcoming Professor Hema Achyuthan. I hope I'm pronouncing the name right.
Yeah, true. Yes.
She's a professor at the Andhra University.
Anna University. Anna University.
Andhra University.
Yeah.
And started her career doing a PhD at the Deccan College in Pune University. Started working in the Thar Desert, and since then has done a tremendous job to extend climatic and geomorphological landscape work to the scale of entire peninsular India. She's been working in other regions of the world and now active in Africa. Lots of experience, international experience, and lots of educational experience, lots of PhD students that benefited from her experience. And we are lucky to have you here talking today about the link between monsoon and its impact on the landscape in coastal Tamil Nadu in India. An interesting point here is that monsoon is not only the summer monsoon that everybody knows, but southern India receives a lot of rain, monsoonal rain in winter from the Bay of Bengal. And it's been always a conundrum how to reconstruct that. And Professor Achyuthan has gone a long way into clearing this subject. Welcome again, and I'm looking forward to this talk. Let's start.
Yeah. Thank you, Professor Liu Gusan. I'm very happy to be here and share my experience in understanding the quaternary landscape of the coastal Tamil Nadu, which receives copious amount of northeast rains, and this rains are also called as the return monsoons. My interest in this particular topic started way back in the late 90s or in the early, mid 90s, when I got married and I shifted to Anna University as a lecturer. And when I was looking up at the landscape, I wanted to reconstruct, with my experience in Rajasthan, I wanted to reconstruct the late quaternary landscape of this region. And I found it extremely interesting because this landscape is very, very, very old. And earlier, looking up at the earlier literature, I read that the landscape was receiving southwest monsoon, and most of the authors were only interpreting the landscape evolution by understanding the southwest monsoon, but not delineating between the southwest monsoon and the northeast rains. So I am very happy to be here this afternoon, morning, evening, wherever all of y'all are, whoever are listening from different places, on the monsoon dynamics and its impact on quaternary landscape of the coastal Tamil Nadu. The outline how do I go to the next? The outline of the lecture is first to give you a brief introduction about monsoon. How does the dynamics of southwest monsoon and the northeast monsoon really works? How far and what is the extent of the monsoonal rains, both southwest and northeast rains, and why coastal Tamil Nadu receives this northeast rains in a very dominant fashion, the geology and the tectonic configuration of the coastal Tamil Nadu, and the main rivers that drain the landscape, the peninsular India, the Kaveri Basin, the Kurtalya, the Palar Basin, and then how you reconstruct the quaternary stratigraphy with some conclusions drawn till date and a few recommendations. Do you know that in India particularly, and in Asia particularly, monsoons are awaited with a great abated breath every year. And this is so because uh, all those part of the continent, the Asian continent, supports a big population of the world, nearly 6 billion population, and all of them, most of the countries are agriculturally oriented, and it is because of the rains that agriculture produce, economy, trade, industrial facilities, everything is connected with the rains, whether it is southwest monsoon or the northeast monsoon. And therefore, uh, monsoons uh, are very important in the national building activity, nation building activity. Um, I still remember every 6th of June when I was a student in Pune, I, we all used to come out and dance when the first rains poured on the dry soil, and the beautiful fragrance of the first rain was really breathtaking. And uh, everywhere this has been awaited with great interest. So this word monsoon is seems to have originated from an Arabic word called the mausim, and this is basically a seasonal wind that reverses the direction according to the changes in the season. For a place like Chennai, there is no season per se. It is only hot, hotter, and hottest. But if you go further north in the latitudes, you do definitely get a big change in the seasonal pattern. Chennai is about 13 degrees north of the equator, and therefore it experiences more an equatorial tropical climate condition or environmental condition. Monsoons, they travel from the monsoonal wind, basically they travel from sea to the land in summers, and from the land to the sea during the winters, and hence this is a double system of seasonal winds. Historically, the monsoons have been very important because these winds were used by the traders, seafarers, merchants, who moved from place to place for business, for business trips, for spices, wood cutting, and many other things, or even transporting people from one place to another for work purposes. Though there is monsoon in the Indian subcontinent, Central, Western Africa, Southeast Asia, northern part of India, the winds are more pronounced, but the winds are more pronounced in the Indian subcontinent. India, particularly the west coast of India, gets the southwest monsoon winds in the summer and the northeast monsoon during the winters. The former arise, the southwest monsoon, they arise because of the formation of the intense low pressure system over the Tibetan plateau, and the later arises, that is the winter rain, they arise due to the high pressure cells that are formed over the Siberian and the Tibetan plateau. So there are several factors that influence the onset of the southwest monsoon. Now, this is basically because uh, intense low pressure formation over the Tibetan plateau because of intense heating during the summer, permanent high pressure cell in the south of the Indian Ocean, east to northeast of Madagascar in the summer period, permanent high pressure cell south of Indian Ocean, subtropical jet stream, African easterly jet stream, intertropical convergence zone, which moves north towards the Tibetan plateau, and that influences southwest monsoon a great deal. The factors that really influence the intensity and the amount of southwest monsoon are the strength of the low pressure over the Indian Tibetan plateau, high pressure over the South Indian Ocean, the Somali jet, the Somali current, and of course, the action of the currents in the ocean, the Indian Ocean Dipole, Indian Ocean branch of the Walker Cell, IENSO, El Nino, La Nina, Indian Ocean Trough, Ickman transport, all these factors, they play a very, very important role in bringing the southwest monsoon and precipitating in the Indian subcontinent. Now, the amount and the arrival time, the amount and the intensity of the southwest monsoon have always varied over a period of time. There are main two branches of the southwest monsoon. These two branches are called as the Bay of Bengal branch, which moves more towards the east, northeast, and the Arabian Sea branch, which moves more towards the west. The Arabian Seaside monsoon, it creates a low pressure area more towards the Thar Desert region. It is but quite strong and quite intense than the Bay of Bengal side of the monsoon. Now, what is the real spread and extent of monsoon rains? Southwest monsoon, they spread across, practically covering the entire India. It tapers more towards the Thar Desert. The extreme part of the Thar Desert receive even less than 120 millimeters of rainfall, but you go more towards the Pakistan side, like the Bawalpur region or the Sindh region. They are practically the central part of the Thar Desert. But what we have in India is not the true desert, but the margin of the Thar Desert. The East African side, the Somali, Kenya, the Turkana Basin, all this region, they do receive the monsoon rain, but it tapers more and more towards the west and the eastern part of Africa. Parts of North and Northwest Australia also receive the southwest monsoon from end May to September. But of course, the amount and the intensity varies. But the northeast monsoon precipitates along the Coromandel coast, parts of North Sri Lanka from September to December. I have been observing this northeast monsoon because of my keen interest in this particular topic. Earlier in the 1980s, we used to get few summer showers in the month of May, and then no rains during June, July, August. But from the beginning of or mid-September, we used to get rains, the return monsoons, and move on up to first week of December. But of late, there is a big change. In the last 5-6 years, there are no summer showers, no rains during the June, July, August, except for a couple of showers you may get for only a day or two. And then during the September, from beginning of September to the end of December. In fact, last year, in 2022, even during the first week of January, we received a good amount of rain. Of course, this was coupled with cyclonic storms that grew in the Bay of Bengal. So just to show you some cartoons which have been drawn from Williams et al. 2016, the spread of the southwest monsoon, the northeast rains, how they come down. And you see that the northeast rains come down because of the shift of the intertropical zone, more going closer to the equator and going further down the equator. So the causes for the northeast monsoon, high pressure cells over the Tibetan plateau, Siberian plateau. They bring rainfall to the southeast coast of Tamil Nadu. Simandra's south coast is also a part of our nation, and you have the little part of the Sri Lankan region, which gets copious amount of northeast rains. Now, this rain particularly brings flood, where the cities are not very well drained and not very well constructed to receive this copious amount of rainfall. It is basically mainly a relief, orographic relief, which is erratic, unpredictable, varies from time to time. It results in floods, and then floods move on to droughts, and sometimes the rainfall occurs early, sometimes it is delayed, it is unevenly distributed. There are places in India, all over India, where some places receive less than 200 centimeters of rainfall. Some even receive less than 550 centimeters of rainfall. Chennai and the coastal Tamil Nadu receives somewhere around 1,200 millimeters of rainfall to 800, 750 to 800 millimeters of rainfall. This is just to show you the Asian modern monsoon system. It shows the movement of the southwest monsoon across India. You can see the various colors where you get more than 1,200 millimeters. Earlier, there was a site named Chirapunji, which received more than 200 centimeters of rainfall, but it is now shifted slightly more towards the northeast. A village, at the moment I don't get its name, but it receives something as similar. It is one of the highest receiving rainfall today in India. Now, you will ask me a question: when did this entire monsoon system really start, and when did it really get established? So, if you look up at the spread of our continents before the Cretaceous period, India was far south of the equator, and due to the plate tectonic movement, the Tethys Sea, the arm of the various seas that bordered the Indian subcontinent, got filled up, got closure. They got closed, and India struck with the Asian subcontinent. It's subducted. There is a suture zone, and therefore the Indus suture zone brought up the rise of the Tibetan plateau, the Himalayas, and all this helped in establishing a monsoonal system. And earlier, when people started working on the Sivalik system, particularly looking up at the Sivalik deposits in Nepal, Pakistan, in India, and using the stable isotopes on paleosols, on calcrates, and looking up at the vertebrate fauna and vegetation and canopy during that period, Serling et al., Quaid et al., they all said it was around the 7 million years from today. But now the same group tells us that it is anywhere between 10 to 12 million years ago that the monsoons really started getting established. And therefore, today we have a pattern that the monsoons start hitting the Kerala coast at the end of May season. It spreads all over the Indian subcontinent. Moves further in Asia and tapers down, but then picks up the moisture from the Bay of Bengal because the Tibetan plateau gets heated up, the Siberian plateau gets heated up, and it directly comes down and precipitates along the Tamil Nadu coast. This has been the pattern for the last, if we take those dates correctly, and if we apply that system, then the region of the Tamil Nadu coast has been subjected to the northeast monsoon rains since the last 10 million years. And this is just to show you the cartoon as to how the Indian plate would have behaved since the last 10 million years. So, often this came to my mind: why are we trying to understand our landscape? Why landscape evolution is important? Did the climate or the environment that is occurring today, the way it is occurring, did it change in the past? What was its intensity? What was the driving force for it? What were its causes? What were the parameters that led to the change? Did it occur in the past? How long was this observed? What were the triggering mechanisms? This is also very important because human migration and peopling in continents, did it take place all at one time, or did it take place in different time? When did agriculture practice get established on the river valley systems, on the river terraces? Was the rainfall the same, or was it the intensity of rainfall same? Was the agriculture pattern shifting according to the rainfall? Did really early man witness climate and environmental change? Did he understand it over a period of time? Did he behave and sculpt the landscape according to the way he required? So these several questions came up, and not many people have answered it. Not many people have answered it. But then I thought, why not have a multi and interdisciplinary approach where you can combine archaeology and geology with time, with looking up at the landscape and see what is happening to the system. So we have in Chennai, around Chennai, near Chennai, we have a fantastic early lower Acheulean site, Athirapakam, which was first discovered by Robert Brucefoot in 1866-68. And this paper was published in Madras Law Journal. And he looked up at the Acheulean tools that were spread on the ferricritized surface. And these were the marine material where an arm of the sea got closed up and then later on reactivated by the, or rejuvenated by the fluvial processes, and you have the occurrence of Acheulean tools. Today, there is a group led by Dr. Pappu et al., who have published 2 good papers in Science as well as in Nature, where they said that the lower Acheulean to be more than 2.26 million years, and the site continued to be inhabited by the Middle Paleolithic people also. The tools have been made on the quartzites, and these quartzites are easily available nearby from the Alikuli Hills and the higher elevated Chittoor and Tirupati area, and also in the Kanchipuram high elevated zones. But before Pappu et al., there were several people who have excavated the site. Dr. V.D. Krishnaswamy in 1948, Dr. K.D. Banerjee in the late 50s, and Dr. Vijula Jaiswal, who produced her PhD thesis in the late 50s and in the 1960s. Also, this also raises another question, that was this region really important for agriculture purpose, because Kaveri Delta is one of the largest delta producing rice today, and it is the rice bowl of India. We produce rice 4 times a year, and this is all because of the shifting and agricultural irrigational practices. So this question arises that when agriculture, rice particularly, started in the Kaveri Delta, and here you have today the origin of agriculture practice in different parts of the Asian subcontinent, and you find in India that you don't find evidence of rice per se, but you have livestock, pottery, agricultural with maize, millet coming from different archaeological sites, particularly from the Ganga basin from the rice, say around 6,000 years from today. So another question, why should we reconstruct paleoclimate and paleoenvironment? Basically, this is to predict paleoclimate and paleoenvironment, to predict the future, because we know one thing for sure, that we had a very famous idiom, the past and present is key to the future, but it is also the past, the the, the to understand the future, we need to understand the past and the present. So to predict future climate to a greater degree of accuracy, you need to also take into account the geological processes that happen on the landscape. There is always a time lapse, both in space and in deposition, and in the intensity and in the velocity of deposition. And all this should be taken into consideration when you use modeling system, especially the GCM and the RGCM climate modeling for future prediction. Now, the cartoon in the right-hand side just shows you the arrival time of monsoons in India, the southwest monsoon, but there is a return monsoon which just comes along the Coromandel coast. Coromandel coast, I can show you here, and this is the region that we are talking about today. So the major rivers of India are the peninsular rivers. They all mostly move, they drain towards the Bay of Bengal because that is the regional slope. And the rivers move through different varieties of rock types of different geological age, and they debouch their sediments into the Bay of Bengal. The major delta systems of this east coast, particularly the Mahanadi, the Godavari, the Kaveri, and the other small rivers like the Palar, the Vaigai, the Ponnayar, they all don't form big delta systems. Particularly the Palar River, it does not form any delta because there is a seismic canyon formed in that region. The breadth of the river near the coast is very, very large. And I'll tell you the reason why it is not forming a delta at that site. Okay, so let's take the Kaveri River because it's one of the largest river in the peninsular India, starting from the Coorg Hills in the western Ghats over here. Moving, it is tectonically controlled. It is the middle region which is receiving both the southwest monsoon and the northeast rains, but then it moves towards the formation of the delta, forming the Kaveri Delta. It travels through the hard rocks, forming the various waterfalls of the Charnockite and the anorthosites of Precambrian age, and then when you come towards the delta region over here, it cuts through the Cretaceous deposits, which have been formed due to the Cenomanian transgression, and then forms the Kaveri Delta moving into the Bay of Bengal. We do not have many dates on the rivers, on this particular river, but of late, Dr. Jaiswal and his team, they have dated the delta, and they don't go. We don't have very old date, but we come up somewhere near the last glacial maximum, 12,000 to 14,000, but still not really touching the last glacial maximum period. So it is dissecting the tertiary sandstone and also the tertiary sandstone. What is very important in this particular slide is that the Cenomanian transgression that took place and formed the Cretaceous deposits, lower, middle, upper Cretaceous deposit, the sea never went beyond that region. It was continuously regressing, forming the younger marine deposits, and therefore you have the tertiary sandstones of the Eomiocene age, and further down you have the Cuddalore sandstones of the Miocene age. So this is just to show you all that how Kaveri and its drainage pattern is controlled by several structural factors. For example, you have the fault zones going from Kumbakonam into the passing through the delta formation, and all this delta material is guided by these faults and the lineaments. You have eye-shaped drainage pattern, and they all indicate that the drainage system of the Kaveri is strongly controlled both by lithology and by structural parameters. There's another IRS satellite data and also the DM data to show you how the fault systems, they are parallel and they move to form the delta system. One question in the mid 70s and 80s was raised by geomorphologists that today what the Kaveri is draining, is it the real original Kaveri or where is the real proto-Kaveri? So we know for sure now that the Kaveri has shifted its drainage pattern more towards in a clockwise direction. But there are some school of thinking where Kaveri has shifted its drainage both in the clockwise and in the anti-clockwise direction. And the Pala River is the one of the branches of the Proto-Kaveri. So you have the southern peninsular rivers where you have just about the Chennai, you have near Kanchivaram, you have the Panar, you have the Quaternary River, you have the Aranya, you have the Gadilam, you have a number of rivers, they drain into the Bay of Bengal. If you look up at the Palar and the Quaternary river systems in near Chennai, if you see very closely, the city of Chennai is drained by the three major rivers, the Adyar, the river Kuvam, and the Quaternary. And of course the Palar, which is moving further down south, and it's a big mega river than the three rivers. These rivers, if you look, they have a similar draining pattern. They all move in a similar fashion, and they are lithologically controlled, and also they are controlled by lineaments. And what is very important about this particular area, right from Pulicat and slightly north of Pulicat, is this, that the floodplains of these four rivers have not merged within each other. It's very typical that they move and they drain the ferricrete and the lateritized Cuddalore sandstone and the upper Gondwana sandstone and shales. The rivers cut they incise or cut the ferricrete and the laterite surfaces, and they form the Holocene terraces, and these terraces have been dated from 9,000 years to 5,900 years, around 1 meter depth, and on the top up to 800 years using both carbon-14 and by OSL method. And if you look up at the general Cortelyar stratigraphy, you find that you have the upper Gondwana sandstone dated from the Permo-Carboniferous period to the lower Cretaceous, which have been completely weathered. And I'll show you a good photograph of that, forming a ferricretized crust over on top, where you have the evidence of early man in the form of Acheulean and Middle Paleolithic tool. And then these ferricretized surface, they have formed in patches rubble and the conglomerate bed with deposits of ferricrete basalt. Now, this makes it very, very interesting, because one question arises is that when did this ferricretization really take place? Is this a slow process, geologically a slow process, or is this geologically a very fast process? What has undergone weathering? Whether it's a parent material, or did the material come from elsewhere and got lateralized in this situation? So, if you look up at the general landscape over here, the entire stratigraphy starts with the boulder bed. This boulder bed is dated to late Neogene, early Pleistocene period, or which you find the process of laterites, and you have the ferricrete deposit. Now, these quartzite boulders and pebbles, they have been used by early men for making stone tools. This is the section that you see in Red Hills and in Shambarambakam area. But one point that I want you all to pay attention to is that just above the ferricritized horizon on the surface, often you see a very thin veneer or a thin layer of Yolin, friable, very well sorted, buff colored sediments. And what does this tell you? It just tells you that this ferricritization is an old process. It is a long drawn process. You have a palette zone, you have the pisolitic duricrust, and you don't find any archaeology within this material, but on the surface you have archaeology, stone tools, and therefore archaeology helps you in dating the surface to a large extent. And this is the on the right hand side you find the tectonic map. You find a geomorphology map of this area where you have the upper Gondwana sandstone shale, lateritization of these parent material, incising and cutting down of this material by the present day Adayar, Kuvam, and the Quaternary rivers. So it is important to understand as to how these ferricrites have been formed. What are the different types of ferricrites? So you find that you have a ferricritized colluvial material, you have a detrital ferricrite material, slabby ferricrites, ferricritized lacustrine sediments, you have ferricritized fluvial sediments, and of course, the ferricritized bedrock. Apart from ferricritized bedrock, which is a primary and in situ formation pedogenic processes which started from the upper Mesozoic period going into the Quaternary, you have the fluvial sediments which have all been transported but have been ferricritized at a different time. You find, if you make thin section micromorphology of these material, you find that they show different formation of ferruginization, microlaminated ferricrete pisolite, cortex of a pisolite, and all this tells you that it takes a geological time for formation, and then for that purpose you also need enough amount of iron oxide present in the system for it to form. That means the landscape should be very moistened. Yeah, the iron should be able to be leached from the system and then reprecipitated in different form to form the ferricritized deposits. So that finishes with a little amount of ferricrete. I can just go on, but still, if you look up at the Kortalyar Kuvam and the Palar lithosection, you can find that they have been dated by carbon-14 because many times within this river fluvial sediments, you get carbonized grains, and they can be dated by radiocarbon material. But then it was also important to date it by OSL to see whether they match or they don't match. And so we also dated it by the OSL method, and they match very well. They show that incision has taken place in the last 800 to 600 years. For that purpose, we looked up at some of the old earthquake data and found that this region is not as stabilized as earlier thought by the earlier workers. We do have evidence of earthquake tremors that shift the channels, and therefore we marked several paleo channels in the Palar, in the Quaternary River, and they are guided by the tectonic and neotectonic activity. and the old and rejuvenation of the old fault and the lineament systems. If you do the sedimentology analysis using MEAL system, Folk and Watt, etc., most of this material, they are very sandy, very coarse-grained material, and they all have been formed. They are all sourced from the provenances from the nearby source. They're not traveling very far distance. They are also very well sorted. They are not coming from a distant region. We paid more attention to the Pala River and its drainage pattern, and we noted that it does not form a delta system. The river mouth near the Bay of Bengal, when it reaches the Bay of Bengal, it doesn't form. Sorry, 1 minute. Hang on. It doesn't form the delta. The breadth of the river over here at its mouth is more than 2 kilometers. That means it's a beheaded drainage system. There is a big structural control, and there is seismically people have identified several canyons in this region, and this just to show you the basin margin fault. And these have been also formed due to not very high earthquake seismic activity, less than 4.5 on the Richter scale. This is just to show you the Pala configuration with paleochannels, with its geology. It's moving from the hard rock to the Cuddalore sandstones, and you find that there are pediments which have been cut by the Pala River. So we looked up at the subbasins of the Pala River. They have been classified. This work was done by one of my students, Reshmi, who published number of papers on this particular topic on the geomorphology, and these papers have been well accepted in the current literature and by other workers. She corroborated her observations and her documentation by running a GPR, and found that there is a fault system occurring at Takkolam in near Vellore on the Pala River drainage, and she found that the subbasin 2 and subbasin 3 are more tectonically active than the subbasin 1 and 4 and 5. So this is just to show you the various drainage pattern which indicate that the Pala River system is also near tectonically active. These are some of the sections that we trenched in the Pala River and in its tributary, the Vegavati River. You find that they have been dated by OSL and by carbon 14 method, and just to show you some more sections which have been continuously dated by and the dates move from 2.42 to 3.26 along the Pala near the Bay of Bengal. She also did the hypsometric integral data, the ratio of the valley floor, found out major 5 subbasins of the river drainage basin, and found that hypsometrically subbasin 2 and subbasin 3, you see that there is a fault line running there, and they are more active than the other subbasins. And if you plot all the radiocarbon dates, the OSL dates of the major rivers along that drain the coastal Tamil Nadu, particularly the Chennai area, you find that the incision has been recently occurring around 800 to 200 years from today. And you can easily mark the late Holocene terrace and the recent terrace along the Palar and the Cortaler River. This is also important to note that you have the seismically uplifted domes, you have seismically lowered area, and they all trigger the tectonic activity of this region. Of this, the most important lineament fault system is along the Pulicat Lake, that is called as the Mulki Pulicat fault line, and this triggers the drainage pattern of the Palar, Cortaler, and the Kaveri system to a large extent. If the Pulicat Lake, where the lineament or the fault system is moving more towards the north, whereas at the Mulki area, the lineament or the fault system is moving more towards the south, and therefore you find that the drainage pattern north of the Mulki Pulicat axis is moving more towards the north, whereas the drainage pattern towards the south is moving more towards the south. And therefore, this was also proposed by Subramania in 1996, and we corroborated our data with this using the geomorphological parameters. And therefore, you find that the Palar River is not able to make its own delta system because of the seismically controlled canyons just below the land margin. And therefore, if you want to build up the entire late Quaternary stratigraphy of this region, you find that you have the Precambrian Charnokites, you have the Upper Gondwana, Satyavedu, Sri Perambuttur formation, and Upper Gondwana sandstone. The Upper Gondwana period is from upper part of the Paleozoic to Lower Cretaceous. Then the region is supported or overlain by the boulder gravel bed, and then you have a big unconformity in this region where you have the Gondwana and the Charnokites coming just opposed to each other horizontally, and over this you have the ferricritized sandstone of the you have the sandstone of the Myo-Eocene period, and that's when the stabilization of the monsoons occurred. And the stabilization of the northeast monsoon played a major role in pedogenesis of the bedrock, and also forming the erosive processes on this landscape. So you have ferricritized colluvial deposits, stream and flood deposits, ferricrit lag and sheet gravel, and then today you have the entire landscape cut by the Cortaler fluvial Palar deposits, and you have within the fluvial deposits, you just have a few megalithic burials, but you don't have the old archaeological tools. Archaeological tools are only found on the ferricritized surface or on the laterite surfaces. So all this took place carving the near coastal landscape, basically owing to the varying degree of dryness, erosion, deposition, varying intensity of causing, varying intensity of pedogenesis, and of course, river incision. This is because the coastal region receives varying amounts and intensity of northeast rain. Earlier, people said it is southwest monsoon, but more and more, I'm very, very convinced that it is the northeast rains that have played a very, very important role in the evolution of this particular coastal landscape. So, just to summarize, after the Cenomanian transgression, during the Cretaceous, late Cretaceous period. The sea has been continuously receding since then. It has been depositing and forming the Eomiocene tertiary sandstones and also the Cartilage sandstones of the Miocene age. But then all these material have been pedogenized to laterites, primary laterites, and ferricrates of these secondary origin. This has been a very, very long drawn process. It has been lateralized even when during the glacial times, of the Quaternary period, although glacial events did not reach this far south of the Indian peninsula. Laterite lithosections suggest a synchronous relationship with the southwest monsoon and the northeast rains. Although many a times northeast rain has not been synchronous with southwest monsoon, both in its arrival, duration, and amount of precipitation of late, especially during the late Quaternary period. Northeast monsoon was stronger and with greater intensity, forming the laterite profile of varying thickness and also causing removal of lateritic soil to form ferricrates of different origin. Early man occupied the surface of the ferricrates, and definitely because the laterites and the ferricrates are formed in an open system, it's very difficult to date them, but at least we can try beryllium-10 to see as to when the surface was at least exposed before man occupied on the scene. Although we now have older dates for low and middle Paleolithic sites from Atira Pakam, but that is only very site specific. What is very important is also the Eoline sediment contribution, which is forming a thin sheet or a thin veneer over the ferricrete surface owing to drier conditions. And also the wind velocity becoming more and more intense. Rivers today are reaching the Bay of Bengal following the tectonically unstable landscape, and the drainage network is dominantly guided by the rejuvenated lineaments and the faults. River terraces are incised during the late Holocene times, and what you find today, if you move along the Pala River, the present-day Pala River, you find that the river is stacking up sediments vertically and broadening its breadth, forming no delta zone like the Kaveri River, often due to flood events. And therefore, the east coast of India is tectonically unstable. Although it receives dominantly northeast rains, near tectonics, unequal intensity of weathering of the bedrock, erosion of the sediments has carved its present landscape. And this is an ongoing process. And since the late Miocene period, the climate fluctuated between humid, wet to subhumid dry conditions. And presently the conditions are drier with stronger wind activity depositing Eoline sediments on the ferricrete surface and river terraces. So understanding and reconstruction of Quaternary landscape is complex and also very difficult, as many factors such as physical, chemical, biological parameters are complexly intertwined. And therefore you need to delineate them. There are the other ways of doing this is also looking up at several other proxies in the region, in southern peninsula region, looking up at high altitudinal lakes in Ooty and Nilgiris, or in the Western Ghats, which can go up to the Holocene period. You can look up at the laterites in the Western Ghats in Kerala, and where you have in situ profiles. You can also study the durecrust exposed that need to be studied and reconstructed for understanding Quaternary paleoclimate shift. But not much work has been carried out in this, looking at these material from my point of view, and therefore the data needs to be generated more rigorously for climate modeling, for predicting future climate shifts. If you look up at the climate models that people are working on, if you look up at the work of Jed Kaplan and his group, you find that there is a big gap of India not yet coming on in their presentation, because they have a very good data collected from the African subcontinent, from the East Asian region, from China, from Australia, but India is still not yet made its place, and therefore this needs to be done more rigorously with focus and discipline, using focused and disciplined protocols. And this can be only done if you pay attention as to how the monsoons behave, the southwest monsoon and the northeast monsoon. And this can be done provided we all work together in tandem. Thank you for your kind attention. I want to thank Professor Peter Clift for inviting me to give this talk. I want to thank Professor Liu Giesan for encouraging me and introducing me to all of you all. Of course, I've been working with you all for a number of years. And I also want to thank my daughter, Mahati Achyuthan, for helping me in putting the slides, because I just got operated yesterday on my eyes. And I thank all of you all for your kind attention. I'm very happy to take any questions that you would.
Thank you very much, Professor Achyuthan. That's great overview of South India, both in terms of climate and landscape formation.
Thank you.
I see a couple of questions here in the chat from Ramanand Yadav.
Yes.
First, it says, if you have any idea when the winter monsoon get established in the past?
Yes. The winter monsoons, it is not like, if we understand the winter monsoons, it is not like what we get in Rajasthan or in northern India. Winter monsoons over there are, the dynamics of the winter monsoons over there are slightly different than what we get the return monsoons or the winter monsoons in the coastal Tamil Nadu. This is more so because the establishment of the southwest monsoon took place nearly 10 million years ago, and this has been very well established using the stable isotopes working on the shivalics from Nepal area, from Tibet, now from Tibet, and also from the shivalics of Pakistan and the shivalics of India. So it is around 10 million years that the monsoons in India really got established. And therefore, the winter rains would have also got established only during that time. I'm not sure if you have any other data on this, but looking up at the shivalic data, this is what I understand from their study. Yes.
And another question says about the Turonian tilting, if it dominated over the transgressive sequencing of the Kaveri Basin.
Yes, it could have accentuated the Turonian and the Cenomanian transgression, would have the tilting during that period would have definitely accentuated the withdrawal of the sea, and pushing, this also was pushing the subcontinent more towards the north due to the plate tectonic area. And there were rains even during that time, but then the southern peninsular region moves more closer and past the equator. So today, Chennai is 13 degrees north of equator, and Kanyakumari is only around 8 degrees north of equator. So it just tells that it indicates that definitely plate tectonics, either Turonian or the Cenomanian time, would have definitely played a major role in depositing the younger marine material and the regression of the sea subsequently. Yes.
Thank you. If there's anybody that would like to ask questions, I open the floor. Please ask the questions yourself, unmute, or send it by chat. I was, in the meantime, I was fascinated by the fact that the process of lateritization is
Yes,
not much active during Quaternary.
it was a very slow process.
So
And today,
it
we
means
find only, one moment, today we find only 30 meter of the exposure, 30 to 33 meter of exposure along the east coast. We don't find anything more than that. And if you find something more than that, that means the parent material would have got lateritized, and there would have been more erosion and transportation. But
what I understand is that the current type of monsoon does not lead to lateritization. So
the current type of, yeah, it leads to, but it's a very slow process. It leads more to erosion, because if you look closer to these laterite profiles, on the surface you have a lot of chrysolites and lag deposits, and then that is now overlain by aeolian sediments.
So what this tells me, in my simplistic view, is that the monsoon before must have been quite different to lead to such different process.
Yes, I agree with you in the sense that the intensity and the amount of northeast monsoon would have been more, because you need to bring, you need to leach out and mobilize the iron from the parent material to get lateritization, to again impregnate iron in the system.
Thank you. I find this illuminating.
Yeah, yes. So there is another example that in West Coast, where you have the primary laterites exposed in Goa, and but now I find more and more the last 2-3 years where I've been working there, I see that many of these laterites are not true primary laterites. They have been all transported, and they have been all relateritized in sections. So if you see a laterite at the sea level, maybe primary, but if you go around 150 meter above sea level or 300 meter above sea level, they are not primary laterites. They have been all transported and redeposited and relateritized, because the Western Ghats themselves have been uplifted over a long period of geological history.
I see.
And then the laterites have not been formed only on Precambrian and Archean material, but the laterites have been also formed on the tertiary material, and they all form a complete cover on the landscape. So definitely, if it has been uplifted at different times, at different phases, then they would have been transported at different times and recently.
Any questions from the participants?
There has been one article by a French group where they have used the magnetite in laterite and microcrystalline magnetites from the laterites, and dated them by using different method, geochemical method, and they have dated them 1 to 55 million years of lateritization, and the other one to around 24 to 26,000 years of lateritization. And from Goa, yeah, and covering the Western Ghats. So this is the latest that
it would be nice to apply the same techniques for the eastern.
Yes, from the eastern coast. Yes.
I don't see much many other questions, so I would like to wrap up.
Yes.
To wrap up this today's talk, and to thank again Professor Achyuthan for a very enlightening presentation on landscapes and monsoon in southern India. Thank you very much.
Thank you.
We're waiting for you at the next monsoon presentation.
Thank you very much. I would like to do one on Holocene lakes. That would be interesting.
Yeah. Not many lakes in India, but the small ones that exist
Yeah.
are very important.
Yeah, I will be in email with you.
Okay.
And I'm
appreciate
very happy that truly it's sincere from my heart that I'm very, very happy that I personally met you in photograph. And I should thank Peter Cliff for this. And I thank you personally for what a beautiful paper that you and your student have been doing on the Godavari Delta. Thank you so much. Thank you.
Thank you very much, and good health with your eyes.
Thank you.
We'll meet again. Thank
Thank
you
you.
everybody for participating.
Bye.